So this is kind of where we finished off yesterday, looking at our arithmetic means. So we are asked to insert 3 arithmetic means between 2 and 9. So that means I have a set with 2 and 9 in it, and I'm going to fit 3 things in between it. So we would really like our arithmetic sequence to be 2 and then 3 new things. So I'm going to put C1, C2, and C3, because then we want to wind up at 9. And we want that to be an arithmetic statement, which means I want them to have a common difference. So we need to figure out what would the difference be between these pieces. So our way to do that with these arithmetic sequences and to be sure it's arithmetic is that we're going to do our a sub n with our a sub 1 plus our n minus 1 times that common difference. We're going to use that formula and the fact that I know that this guy is my first term. This will be my second term. I don't know it yet though. This is my third term. I still don't know that one. I don't know my fourth term, but I know a sub 5 is going to be 9. So we can use that information. Yes, dear.
So this, like, when you keep going, it stops at 9?
Yes. So when we're inserting them in between, it's going to stop right there. We're making a finite sequence.
Can that be entered or no?
Say it again.
Is 9?
So 9 is going to be what our a sub n equals. 5 is going to be our n. So let's do this. We're going to put our a sub 5 here. Just filling pieces in a little bit at a time. We're going to put our a sub 1 here because our 5 is our n. And we want to find that common difference. So we know our values of a sub 5 and a sub 1. A sub 5 was our 9. A sub 1 is that 2. And 5 minus 1 gives us 4 times that common difference. What do we do to solve for that common difference? Subtract 2, so that gives us 7 equals 4 times d. So our common difference is 7/4 or 1.75. You can do it as a fraction or as a decimal. I genuinely do not care. But that lets us know how much space needs to be between each of these for that to be an arithmetic sequence. So we need to find each of these pieces as well. So how can I find my first one, that C1? Careful. We're going to add the 1.75. So we're going to take our 2 plus our 7/4 or our 1.75. Bless you.
Thank you.
So what are we going to do for our second one, C2? Yeah. So we're going to have our 3.75 plus the 1.75. Yeah. Yeah, 5.5. Sorry, I have them written as fractions in my book, so I'm having to mentally convert, but that's okay. So then our third one, C3, $7.25 sounds right. So those are our values. So I could write my sequence here as our 2, our 3.75, then our 5.5, then our 7.25, ooh, there we go, then our 9. If I continued that trend, if I added my 1.75 again, I should wind up exactly at our 9. These have that same common difference. So these are our 3 arithmetic means. This is our main sequence there. Okay, questions on this one? We're gonna do one more, very much like it. Except instead of asking you to put in 3, we're gonna do 6. Doesn't change what we do. Just changes some of the numbers because we've done it as 3 arithmetic means a couple of times in a row, and I don't want us to think it's always gotta be 3. So we did 6. It does not have to be a unit of 3. I don't know why we did units of 3, but just apparently we were in a 3 mood when we wrote it. So we're going to do 6 arithmetic means between 52 and negative 56. So that means my first term is 52 and my very last term is negative 56. So when we're looking at our set here, we're going to have our first term as 52, and then we want to put 6 new things in between. So we're going to have our C1 and C2 and C3 and C4, boom, and C5 and C6. So we're doing 6 of them. That is one reason I do sometimes recommend doing it as the sub numbers, is it's easier to keep track than if I did A, B, C, D, E, F, G. Because then we have our negative 56. So 52 is our first term. We know that's going to be our A sub 1. What is 56 going to be? A sub what?
7.
8. A sub 2, A sub 3, A sub 4, A sub 5, A sub 6, A sub 7. Okay, so when in doubt, you can write them all down. You don't have to write them all down. We just need to know what the first and the last one is, but just be really careful. Because this is our first and our 8th. The process is the same. We're going to do exactly like we did on the last one. We're going to take our formula that has our A sub n with our A sub 1 plus n minus 1 times our common difference.
So negative 56 equals 52. So 52, 8 minus 1.
Substituting all our pieces in here. So we get our negative 108. Where'd I lose you?
Why are we trying to use that 108?
Well, I subtracted 52 from both sides. I'm just making a couple of jumps because I heard a lot of us working ahead. So I filled in all my pieces here. Subtract.
I thought we were going to put the A.
So we put our A sub n over here. So my negative 56, this is my 8. This is my first term, the 52. We did 8 minus 1 because our n was 8.
So I just put the A over here and over here.
No. We got to put what A sub n is, not just our n. So what is our common difference on this one?
The fraction.
The fraction.
Oh, well, negative 108 over 7.
It's not a pleasant decimal. So honestly, we probably gonna leave this one as a fraction because it is unpleasant. So we know our common difference here. So then what we're gonna do, we're gonna find all the pieces in between. So we can do these in the calculator, like it's totally fine. But we're gonna find our A sub 2.
Hello?
That one should not wind up negative. For the first one?
No, that's just D.
Oh, okay. I was gonna be like, that one should not be negative. I'm like, I don't know what this is a decimal because I don't know. So let's find our C1, which is our second term. Looks about right, but I'm gonna go with fractions because, so I'm gonna take my 52 And we're going to add our common difference of negative 108 over 7. You can do that in the calculator. It will spit it out properly with a nice fraction. 256 over 7. Which, if you want to get that as a decimal, is totally fine. Hit the button that looks like this to get a decimal. I don't know what it is, but you can hit that button if you genuinely hate fractions that much. But honestly, it's more accurate to leave it as a fraction, so I'm going to leave it like that. You do not need to have it as a decimal. 256 over 7 is plenty. So then we can find our next ones just by adding them together. So we have our 256 over 7 plus our common difference of negative 108 over 7, or minus 108 over 7.
143.
I've got 148. Somebody double check it, because it's entirely wrong that I made a mistake. Or it's entirely possible. I have 148.7, but double check me. 256 minus 108.
Yeah, it's 148 over
148. But when we leave it in the fractions like this, they're actually already with their common denominator. So really all I need to do for my numerators is subtract 108. Subtract 108. Subtract 108. So our a sub 3,
40 over 7.
it's going to be 40 over 7. Our a sub 4, negative 68 over 7. A sub 5, negative 117 over 7. Present. And then our last one, a sub 6. Oh, wait, 68. I was going to say, it shouldn't be 117.
I have 176.
176. There we go. I heard 117. 176 is what I had. And then our last one, negative 176 minus 108. Negative 284 over 7. If you do it again, if you subtract your negative 108 over 7 again, you should wind up exactly at negative 56. So these pieces all fit. And if you do it this way and then you do your transition one more time, you should wind up exactly at your last number, and that lets you kind of spot check it as you go. Okay, so finding our arithmetic mean is annoying, but not super complicated. Questions on these two that we just did? Because then we're going to bounce around and catch up a couple of the ones that are from the other kind of zones. So we're going to find a sum from 1 to 18 of 1/2 k plus 7. There it is. Let's take a look at this guy. What do we notice? Yeah, we can substitute the 1 in for the k. So let's find our a sub 1. Let's find that bit first. We have our 1/2 times our k, which is 1, plus 7. That gives us our 7.5. Yeah, this is an arithmetic sequence. So we can use kind of the s sub n's to get there. We can use the formula where we take our n over 2 with our a sub 1 plus our a sub n, finding those sums. So we can find our a sub 1 and we can find our a sub 18, our stopping point, because this is an arithmetic sequence. We're going to have our 1/2 and then we'll do our 18 plus 7. What is 1/2 times 18 plus 7? 16. So we know our a sub 18. So since we have an arithmetic sequence, because we have this common difference, it's a linear statement over here, we can use this guy where we're going to find our sum of the terms from 1 to 18, so S sub 18, whoa, wrong pen. We can write that as our fraction over 2 of our 18 terms, where we're taking our first term, that's 7.5, plus our last term, that's 16. So we can find these pieces. When we have an arithmetic sequence, we can take this little shortcut here. It makes it a lot easier to deal with. 18 over 2 is 9. And our 7.5 plus 16, 23.5. So we can do 9 times 23.5. So the sum of these 18 values would be what? 211.5. So this is our answer here. That's our sum. That way we don't have to figure out 1 and 2 and 3 and 4 and 5 and 6 and then go cross-eyed looking at all those values. So adding up all the pieces, we get our first term, our last term, and we add them together like this. Questions on this one? Still wanted to touch a summation. So let's look at this one. So we're going to express this as a sum. So we're going to find our sigma and its rule. And then we are going to find the sum of the series. So we need to figure out what our rule is for this, how it goes from one step to the next. So our steps we need to do, I'm going to give us like a checklist of things to do. We need to find, hang on a second, our common difference. We're going to get an equation for a sub n so that we can write our sum. That's what we're looking for. We're trying to get like our sigma sum from k equals 1 to n, whatever our n is going to be. We also need to know what number this is in here. We don't know. So look at how these are changing. Figuring out our common difference. 11. So we know our common difference is a positive 11 because it is adding 11 here. We are adding 11 here. It is adding 11 every time. So we're going to write our kind of generic equation for a sub n, how we can find any possible number. That's where we're taking our a sub 1 plus our n minus 1 times that common difference. But we're going to make it for this specific equation or situation. So our a sub n here, what is our value of a sub 1? 8. It's this guy here. So we're going to have our 8 we're leaving the n as an n, minus 1, times our common difference of 11. Because we don't know what the n is here. We're trying to make our generic equation. So we're going to have our... So our 8... So our a sub n, our generic equation for this situation, 11n minus 3.
So when we sub in 16,805 for an?
Yep. Because in order to do our sum, we need to know our first term and our last term, and we need to know what number it is in here. So we don't know what this n is. We need to find that. So we're going to put that guy in for the a sub n. So let me grab a different color real quick, just because I've used purple for a lot of things and I need a new one here. So we're gonna take our 16,805 and we're gonna do that with our equation here, 11n minus 3.
1,528.
Yep, we're gonna add 3 to both sides. So I was like, wait, huh? 1,608 equals 11n. Divide by 11. So our 16,805 is what number in the series? 1,528. So there is a lot of terms in this sequence. We should probably not find each term to add them all up. That would take a very long time for 1,528 pieces to then add up. Ew. So let's use our sum that we want to do from 1 to 1,528 of our rule. We can write it this way. It's not pleasant, but we can write it. This is doing the exact same thing of our 11n minus 3. This is doing the exact same thing as if we find our S sub 1,528. Because this is an arithmetic sequence. We're having that common difference where we're adding 11 each time. So we can do our n 1,528 over 2 times the sum of our first term. We know that one. That's that 8 we have at the very beginning. And we know our last term. A different color here. It's this 16,805. We know that guy. So we can find the sum of this whole sequence now that we know that number. So find it. What is our sum going to be? Big number. That is going to be 12,845,132. We do not want to add those all up individually. So this is our sum. That is not a highlighter. This is the sum of our sequence here. Okay, so these two statements mean the exact same thing. The sum of the sequence starting at 1 going to number 15,028 of our function rule, same guy. Since it's an algebraic sequence, this is a linear statement here, we can do so. Okay, what's up? Oh, yeah. Yep, and then 9:30 group. Awesome sauce. Okay, let's do one more. Slightly different look at it, but it's the same kind of stuff. So now we're going to find the number of terms in the sequence. So we're asked to figure out what n is. If I know my first term is -2, I know my common difference is 1/4, and I know my sum is 21. So be super careful about it because we are going to use our S sub n formula here. Just be careful because this is our n over 2 times our either. We can do the a sub 1 plus a sub n. Only problem is we don't know a sub n. So let's try the other formula that we have, that 2a sub 1 plus our n minus 1 times d. So those are pieces we know. for the most part. We have n in here twice that we don't know, but we can solve that. So we know our S sub n is 21. We know our common difference is the 1/4. And we know our a sub 1 is this minus 2. So we know these pieces. So let's substitute them in. Got our 21 equals n over 2 times 2 times negative 2.
Wait, so SN is the amount of terms there are?
So the n is the number of terms there are. Sn is the sum of that many terms. So like on this guy, S sub 1,528, because that was how many pieces there were we were adding together. So the little number on the bottom is the how many. It's like our end number up here. So this is, we don't know how many pieces they are, but they all added up to be 21. So we don't know n, but we have our minus 1, and we did know our common difference of 1/4. So this is how we'd fill in the pieces we know. Let's do a little simplifying because this is a hot mess of crazy. Got our 21 equals n over 2. 2 times negative 2 is negative 4, plus our 1/4 n minus 1/4. I'm going to switch this out for a set of parentheses now that we have way less grossness. What do we want to do next? Many options through. Adding the negative 4 and the negative 1/4. So we've got our n over 2. What do we have left in here? 1/4n. Minus 4.25 or minus, like keeping doing it as a fraction, it's either way. I was like, you can multiply both sides by 2. I'm going to bring this up over here just because I'm running out of space. So if you want to multiply both sides by 2, totally fine. We're getting 42 equals n times that exact middle bit. 1/4 n minus our 4.25, or what is that, 17/4? Whichever way, doesn't matter. Then what? Distribute the n, valid. So we've got 42 equals 1/4 n squared, gross, minus our, I'm gonna switch this to fraction. I just prefer that, but that's just me. You don't have to. If you wanna leave it as 4.25, that's fine. I'm just putting it as my minus 17/4n. Subtract the 42 from both sides. We'd love that, because that is going to make this equal 0. N squared minus 17/4n minus 42. What are we noticing?
Nothing. I told you, man. It's leave algebra 2 for a last.
It's a quadratic. What can we do to make this less gross? You don't even need to use sub. Multiply both sides by 4. 0 times 4 is still 0. If I do this side times 4, we get rid of every single one of the fractions. It's going to give us n squared minus 17n minus 168. That's doable. That's gross. That's doable. That is X factorable. What are we going to get factoring this one? What do we get as our factors?
14.3.
Negative 168. Watch your signs. Multiplies to be a negative 168, adds to be negative 17. Seven and 24, but which one's going to be negative? The negative 24, positive 7. So we have two different possible options here. What are our possible solutions? N equals 24 or n equals -7. When we are looking at our sequences and things like these, can I have a negative in one of these sequences? Let's look at this one where we numbered them. Because we start at 1 and we keep counting. Negative would be before my curly bracket. So how many terms are there here? 24. It has to be this one. Because the n, remember, it's our integers, our counting numbers. We're not going negative. So this has 24 terms. This is probably the hardest kind of question they ask in this section. N's don't go negative. It's the number of things we're counting. So I can't count negative items. Okay. Questions on this one? This is as bad as they get, really. Question? Okay. Cool. So that leaves us with about 10 minutes. So I do have, if you want, I think I gave them to you guys, the review for the quiz, if you'd like to have it. If you don't want to do it, that's okay. It is not required. But I have them. I gave them to you guys yesterday. But if you guys have questions on that or questions on homework or anything like that, now's the best time to ask them. What's up? Yes, I can read the slide. There you go. What's up? You should have your question.
So for some of the things in 10.1 that we learned, we didn't really use the formula for the test. So like, let's say if we solve a problem like on a test, we don't use a formula. Are we still gonna get points?
Like what? Like finding the next term in the sequence, or?
Yeah, like some of the early stuff we did like in 10.1.
No, I was like, a lot of times I do not need like tons and tons of work. If you can even do it with like an arrow or just saying plus that, totally fine. If you can, like I have half of them where I just straight up put an answer down. So giving me as much as you can is great, but I'm not super petty about it. Because I do know that there's going to be several processes that you guys can do in your heads. Just don't do all of it in your head. Give me some.
What's the new formula we learned yesterday?
Say that again.
What's the new formula we learned yesterday?
Someone, we mentioned it the day before, but we worked it for the first time really yesterday. What's up, Zan?
Can I get a read?
Yeah.
Girl.
Yes, I will make it.
Actually, like 4 pages of emotion on this page. Ignore your gross text.
Wait, where is that study guide?
That's all I got. That is the end of them.